Hello, my dear students. You're welcome. It's Dr. Cliff. Today we are going to be discussing something very important, and that is the differences between strong acids and weak acids. Now, what are strong acids and what are weak acids? Now, strong acid. An acid is said to be strong, not because it's so hard or firmly rigid. No, that's not what it means. Okay? I don't know if you were thinking that way. That's not what a strong acid means. Okay? A strong acid is not strong because it's hard or rigid. No, that's not what it means. Okay? Or an acid is weak, not because it's feeble or not because it's feeble or less rigid or soft. That's not what it means. So we are going to discuss the actual meaning of strong and weak acids. Okay? So let's get started. Now, what are strong acids? An acid is said to be strong when it ionizes completely in water. That is the very first point of definition. Number one, strong acids, they ionize completely in water. So weak acids, they ionize partially in water. So you can see that. So strong acids ionize completely in water. That is to say, they have 100% ionization. Ionization in water. In water. So that is what it means. So that is what a strong acid is all about. So when an acid dissolves in water and it has 100% ionization, that is to say it completely ionizes or it completely dissociates in water, we say that acid is strong. So when an acid dissolves in water, it ionizes only partially in water, then we say that acid is weak. So you now understand what a strong and a weak acid means? Now, all right, so that is why they are called strong and that is why they are called weak, okay? Because they ionize partially in water. So strong because they ionize completely in water. Okay. Now, how do we demonstrate this further? It's very, important. Okay. Now, let's say I have five moles of hydrochloric acid. Everybody, hydrochloric acid is a strong acid. Okay, mineral acid is really strong acid. I dissolve 5 moles of hydrochloric acid in water. So okay, now this is water. This water molecule. Now 5 moles HCl, H plus Cl minus, H plus Cl minus, H plus Cl minus, H plus Cl minus. Okay, 1, 2, 3, 4, 5. So the 5 moles got completely ionized. They got completely dissociated in water. Okay, so if I take the same 5 moles, let's say acetic acid. Acetic acid is an organic acid. An organic acid generally are weak acid. So if this dissolve in water, if you dissolve this in water, 5 moles of acetic acid in water, we're going to be having, okay, let's say this water molecule. So I dissolve it in water. This is what I will have: CH3 COO minus H plus, CH3 COOH, CH3 COOH, CH3 COOH, then CH3 COOH. How many? 1, 2, 3, 4, 5. Out of the 5 moles, only one got what? Dissociated. Only one got ionized. Now you must know that the term ionization and dissociation could interchangeably be used. Okay? Ionization and dissociation could interchangeably be used. All right. So if I say strong acid ionize completely in water, it means I could also say they dissociate completely in water. It means the same thing. So weak acid, they partially in water. Well, we could also say they dissociate partially in water. All right, you can see that completely the 5 moles got completely dissociated in water. In this case, 5 moles acetic acid, they got ionized in water. Not that they won't get ionized, they get ionized, but only partially will they become ionized. Only partially ionized in water. So you can see they were only what? They ionized partially in water. So this didn't get dissociated, didn't get dissociated, didn't get ionized. So only one got ionized, which is this molecule. So this, how many moles? This did not get what? Ionized. Okay, only one mole got ionized. All right, you can see this is indicative of what? Partial dissociation. Why this is indicative of what? Complete dissociation in water. All right, so that's the very first point of difference you must know between strong acids and weak acid. Now, point number two. Strong acids, they have high amount of hydrogen ion or ozonium ion. Ozonium ion is H3O plus. Ozonium ion or hydronium ion is also called hydronium ion in solution. So for this, they have what? Low amount of H plus or ozonium ion in solution. All right. Now you know the reason why. Based on by looking at this, you can see why it is like that. So they have high amount. Strong acids have high amount of hydrogen ion in solution. Why? Take a look. You can see that they are going to have. This is what we call large amount. This is huge, right? Large amount of hydrogen ion in the solution of the acid. Okay, so but when you come here, you have just one of these. So we can call this we can call low amount. Okay, low amount. Okay, low amount. So you see what we mean. So that's why we say they have high amount of hydrogen ion or H3O plus in solution. Now, this is because they dissociate, they ionize completely in water. So because they ionize completely in water, so they will be having high amount of what? Hydrogen ion in the solution. Why? Because we can see ionize partially in water, so they will be having what? Low amount of hydrogen ion in solution. Now, the reason why we could also say H3O plus in the place of hydrogen is simple. Now, H plus does not practically stay in water. It will rather associate with water molecule to form what is known as what? Ozonium ion. Okay, H plus does not remain solitary in water. So this H plus will associate itself with water molecule to form what is known as what? Ozonium ion. So which means that if the hydrogen ion is high, therefore there will also be high amount of what? Ozonium ion. So for weak acid where the what? Hydrogen ion is low. So you expect the ozonium ion to be what? To be low. Okay, so that is the explanation to that. You can see this is a classical demonstration, a classical explanation to what is strong and a weak acid are. Okay, now let's go to the next point of definition. Let's go to the next point of difference. Okay, the next point of difference, number 3. So strong acids, they have high Ka. They have high Ka. 3. For weak acid, they have low Ka. Okay, they have low Ka. So weak acid, they have low Ka. Now why? Now when we talk about Ka means what? Ka means acid dissociation constant. Okay? Or you could call it acid ionization. Acid ionization what? Constant. Okay, that's what it means. Now, for strong acids, they ionize completely in water, right? They dissociate completely in water. So because they ionize completely in water, they dissociate completely in water. So that's why they are going to be having a high Ka. So for weak acid, because weak acids ionize partially in water, because they dissociate partially in water, so they are going to be having what? A low Ka. So that's why they have low Ka. You get it? It's commonsensical to think that way. Okay, so strong acids, they have what? High Ka, because they ionize or dissociate completely in water. So that's the reason why their Ka will be very, very high, to be massive. Why for weak acid? Because they ionize partially in water, because they dissociate partially in water. So you expect their Ka to be what? To be low. Acid dissociation constant. So they do not dissociate completely. They do not dissociate completely in water. So they will be having low, Ka. So because strong acids, they dissociate, they ionize completely in water. So you expect their Ka to be what? To be high. So it's commonsensical to think that way. Okay. All right, let's go to the next line of difference. Point number 4. Point number 4. Strong acids, they have low pKa. Okay. Why weak acids, they have high pKa. Now why? Why is it so? I will explain. Don't worry, I got you. Okay. Now for weak acids, now look at it. You should be knowing in chemistry that P means minus log. Okay, so P in chemistry means minus log, which means P is equals to minus log. So that's why pH is minus log H. So it just left for you now to put this. Okay, so that's why similarly, when you have pKa, it will be what? Minus log Ka. All right. So it's just like saying put K here. Since you already know P is equal to negative log, because P means minus log. So if you put pKa here, put Ka here. So you can see that pKa is equal to negative log of what? Ka. So when you are asked what pKa, what is pKa, what it means, pKa is simply what? The negative logarithm of what? Acid dissociation what? Constant. Or you can say pKa is the negative logarithm of acid ionization what? Constant. So mathematically, let's discuss how it relates to point number 4. Okay, let's explain how. Now, this is what it means. This is what we need to know. Now, P, we've established a mathematical fact that pKa is equals to negative log of Ka, right? So from here, mathematically, pKa is equals to log 1 all over Ka, isn't it? From here, we can easily say that pKa is inversely proportional to Ka. All right. Is that not what we see? This is what we see. pKa is equal to log 1 over Ka, which we can easily relate as pKa. pKa from here is inversely proportional to Ka, right? If you don't want to see minus, this and this be the same thing. Okay. From here, pKa is inversely proportional to Ka. That's why we have this. Now, from here, you can see that for strong acid, they usually have what? High Ka. For strong acid, they usually have high Ka. Then you expect their pKa to be what? To be low, because they are pKa and Ka, they are inversely related, isn't it? So that's the explanation. All right. So for weak acid now, for weak acid, pKa is inversely proportional to Ka. Then for weak acid usually have what? Low Ka. okay, because they have what? Because they ionize partially in water, isn't it? So they usually have low Ka. So then their pKa should be what? Should be high. So that's why we say weak acid have low Ka, they have what? High pKa. So if you have low Ka, then you should be having what? High pKa. Therefore, strong acids that have high Ka, they should be having what? Low pKa. So it's commonsensical to think that way. All right? Good. Let's move on to the next line of difference. Then point number 5. Strong acids, they produce weak conjugate base. Okay? They produce weak conjugate base. Why? For weak acid, they produce what? Strong conjugate base. Okay? Good. Now, what does that mean? You should be knowing that acid minus proton is equals to conjugate what? Base. So when an acid loses a proton, what it gives rise to is called a conjugate what? Base. Okay? So what do I mean? For example, I have HCl, hydrochloric acid. When an hydrochloric acid loses its proton, H plus, it becomes what? Cl minus. So this is the acid, right? So this is the acid. This is the what? Conjugate what? Base. So because HCl, everybody knows that hydrochloric acid is a strong acid. So strong acid will give rise to what? A weak conjugate what? Base. Okay? A weak conjugate base. So that is what you need to know. Okay? So if we come here, so let's say we have CH3COOH. Okay, I think I should take it here. CH3COOH. This will give us CH3COO minus, then plus H plus. So you see this, we all know that this is a weak acid. So acetic acid is an organic acid, and organic acid generally are what? Are weak acid. So this is a weak acid. Weak acid will give rise to what? A strong conjugate base. Okay, now an acid will give rise to what? A weak conjugate base. A weak acid will give rise to what? A strong conjugate base. So that's a fact you must know. Okay, so I have discussed this. Okay, we're going to discuss this in a different video. Okay, endeavor to watch that. Point number 6. Now that reminds me, let me quickly ask you this question. H2SO4. Okay, the conjugate, now H2SO4, the conjugate base of H2SO4 is what? Is HSO4 minus plus H plus. Okay, so this is the acid and this is the conjugate what? Base. Okay, you must be knowing that the difference between an acid and its conjugate base is 1 proton. So which means an acid differ in chemical composition from its conjugate base by how many proton? 1 proton. So don't be tempted to say that the conjugate base of H2SO4 is SO42 minus. Okay, never you say that. Okay, this is very, very wrong, because the difference between this acid now and this conjugate base is not 1 proton. So this is wrong. Okay, this is not the conjugate base of H2SO4. So the conjugate base of H2SO4, if you're asked, is HSO4 minus. Okay, it's just like if you are asked, what is the conjugate base of H2CO3? The conjugate base of H2CO3 is going to be what? Is going to be H plus HCO3 minus. So HCO3 minus is the conjugate base of carbonic acid. So this is the acid and this is the conjugate base. Okay, so carbonic acid is a weak acid, so it's going to give rise to what? A strong conjugate base. So if we say this is a weak acid will give rise to what? A strong conjugate base. Good. All right, so that is what I need you to know. So I will discuss this in a separate video. Okay, So endeavor to watch that video, okay? Conjugate acids and bases. Okay, that will be discussed in this. Now, point number 6. Now, point number 6 you need to know is that they have low, strong acids have low pH. Okay, why what? Weak acid they have what? High pH. I will need to explain this to you emphatically so you can understand what it means. Now, don't get it twisted. This could be complicated. All right. Now, you must be knowing that the pH scale ranges from 0 to what? To 14, right? Okay. Now 7 is neutral. Okay, neutral. Okay. Now from 0 to 6.9 is acidic pH, acidic region. While from 7.1 to 14 is what? Is basic or alkaline. Okay. Now, so which means for a substance to be an acid, whether weak or strong acid, whether strong or weak, they usually have a pH less than 7. Okay, so an acid cannot have pH greater than 7, whether it's weak or not. It must always have a pH less than 7. Now, imagine we have 1 molar HCl, okay, and 1 molar acetic acid. Okay, now the pH of 1 molar acetic acid, let's say it could be 1. Let's say it could be 1.1. Okay, why the pH of 1 molar acetic acid could be, let's say 4.9. all right, we're just saying. Okay, now you can see that for a strong acid and weak acid, if both have the same concentration, 1 molar, this is concentration, 1 molar, this is the concentration of this acid. Both here have the same concentration. So if both have the same concentration, if both strong acid and weak acid have same concentration, anytime, any day, you expect the pH of a strong acid to be lower than that of what? A weak acid. Did you get that? Now, but when the concentration varies, that is to say, this is what I mean. When the concentration varies, let's say I'm now having 0.001 molar HCl. Here I'm having 0.1 molar acetic acid. Then you expect the pH of this is 4. Okay? Yeah, it's 4. Has a pH of 4. Why for weak acid, the pH is going to be approximately equal to 2.8. Okay? You can see there's a difference now. The difference is due to what? The difference in concentration. So this strong acid has low concentration. Okay? Low concentration. Okay, you can see 0.01 molar. This is the concentration of this. pH is dependent on concentration. So pH depends on concentration. Okay, so pH depends on the concentration of the acid. All right, so if the concentration of the strong acids and weak acid are the same, anytime, any day, you expect the pH of a strong acid to be lower. Okay, so that's the reason why we say for strong acid they have low pH, for weak acid they have high pH. This idea should be based on when they have the same concentration. Okay, so when they have same concentration, so I need you to understand that when they have same concentration. So this is because from the mathematical relationship we have established already, you know that pH is equals to negative logarithm is equal to G ion concentration to base 10. Now from here we can say that pH is equals to logarithm log of, okay, now pH is equals to this, right? This is the same as this. So we simply say that pH pH is inversely proportional to hydrogen ion concentration, isn't it? Now, from here, you can tell that for strong acids, they usually have what? High amount of what? Hydrogen ion in the what? In the solution, right? So if they have high hydrogen ion concentration in the solution, it means they will have what? They will be having low pH. So that's why their pH is expected to always be low, around 0 point something, 1 point something. Okay, always low. It should always be low because they have what? Low amount of what? They have high amount of hydrogen ion concentration. So having high amount of hydrogen ion concentration means having a lower what? A low pH, because of the inverse relationship that exists between pH and what? Hydrogen ion concentration. Therefore, weak acids, we know that for weak acids, they usually have what? Low amount of what? Hydrogen ion concentration in the solution. So because of that, they're going to be having what? A high pH. So that's why we expect the pH to be high. But it will not be high to the extent that it will not be more or greater than 7. No. Acids usually have pH, whether it's weak acid, they usually have pH less than 7. All right. So that is the point of differences you need to know, or these are the point of differences you need to know. All right. So we have come to the end of this tutorial video. So these are the things you need to know about strong acids and weak acids. So as a university undergraduate, you're supposed to know these differences. Okay. You shouldn't just be headstuck to that one definition of acids are substances that ionize completely in water. So you shouldn't just be headstuck to that, or weak acid that ionize partially in water. So there are other more to explore, which we have just done. So it's Dr. Cliff. Bye for now.